Hi, welcome back to another episode of Algebra in Words, the video series. In this video, we're continuing our discussion on solving and graphing quadratic equations and functions. And in this video, we're going to focus on one method of solving, which is called the complete the square method. If you want to follow along in written form of the method that we're going to go over, because it will involve a few steps, you can find it in my book, Algebra in Words 2, starting on page 91. And I walk you through the steps step by step along with an example. But of course, we're going to go through it in this video as well. So let's get started. Now, where we left off last video, we were looking at what's known as the vertex form of a quadratic equation. And I left that up here. Throughout this video, I'm going to pause where we're at and show you how it relates to what we're doing in complete the square, and how you can convert it back into the vertex form of the equation. But for now, we're going to look specifically at the complete the square method for solving quadratic equations. This is basically just one of a few methods that you can use to solve. Now, some people might ask, what is the reason and when is the time to use the complete the square method? Well, there's a couple answers to that. One answer is, when you cannot factor and solve as a quick way to find the solutions or the x-intercepts, then one way that you might use in place of factoring and solving is the complete the square method. In truth, the ultimate default method to use would be using the quadratic formula, in my opinion, and I'm going to go over that in the next video. However, complete the square method is one method that will work almost foolproof all the time. Now, but there are purposes for the complete the square method. One purpose is because you can use this to convert back into the vertex form. And so if you're looking for a way to not only solve to find the x-intercepts, but also kind of find the vertex form along the way, this way accomplishes that. Also, there's kind of another later purpose for the complete the square method. And although we can use it here, when we get to circles, which we'll look at in a few videos later, converting one form of the equation for circles into the standard form of circle equation, you do need to also use and be familiar with the complete the square method. So there is a reason and a purpose beyond this for that method. So anyway, let's get started. Now, to do the complete the square method, it's very important that the form of the equation is in the proper form. And what I mean is, there are really two things that you need to have in mind. Really, I guess three. They're kind of the same, overlapping. The first is, you must have your equation in standard form, like this. And basically what that means in this case is, all the terms must be on the same side, and it should be in descending order. That's what we know as standard form, and I have that written above. I'm sure you're familiar with that at this point. But there's one other little detail that's important for this, and it's kind of one detail, sort of two. And that is A. To do the complete the square method, you must have A where A is 1. And what that would look like is, it would look like no coefficient in front of x squared. Okay, when the coefficient is not written, we understand that to be 1, and the 1 is unwritten. But to do the complete the square method, A must be 1 or have no coefficient. It also would need to be positive. So again, when it's positive, we don't write anything for that, but again, we need to recognize that it does have to be positive. If A would come negative, then we would have to change the signs by dividing every term by -1, and that would properly convert the sign of A into positive. Likewise, suppose A came as a coefficient other than 1. Suppose it came as coefficient 3. How could we account for that? Well, then what we would need to do is, we would need to divide every term by whatever A is, because by doing that, that would then make A 1, and then the other coefficients or numbers would adjust accordingly, and then we could continue from there. So now that we know that, let me walk you through the steps that you're going to do the complete the square method. as well as kind of what to expect along the way and how to expect it to end. So here's what you're going to do. Here are the steps. There's a few involved. The first thing is, once you have the order in proper place, then what you're going to do is you're going to move C to the other side. So in that case, that would be this. It might be positive, it might be negative, so whatever it is, you might need to do the opposite to it, add or subtract it, but you need to move C to the other side. Okay, and when you do that, I like to say leave a little space, and I like to write the space on the left and the right. Then what you're going to do is, using the remaining ax squared and b plus bx term, you're going to use that and you're going to create what I call the new c. I'm going to show you the basic formula to find the new c. And once you find the new c, you're going to add the new c to both the left and the right, and you do that to make sure that the equation stays equal on both sides. But the reason behind making the new c is because that's going to automatically create a perfect square trinomial on the left. And on the right, you're just going to combine the old c with the new c, and then that'll be whatever it is. But on the left, as I said, it's going to create a perfect square trinomial. And that's very strategic, because if you remember, as we went over in previous videos of special case factoring of quadratics, you can always factor a perfect square trinomial into a binomial squared. And that's the key to this, because we need to do this to create a binomial squared on the left equal to a number on the right. Once we have that in place, then the way that we see this to the end is to apply what's called the square root property, and you already know what that is. That just means that you can take the square root of a perfect square to get the radicand, or to solve that. And then from there, you basically just sort of simplify it out to find the x-intercepts of whatever x is going to be. And you might, in that case, get one solution or two solutions, or in some cases, you might get two complex number solutions. So I'll walk you through that. But without further ado, let's get started. So I have an equation up, and it is x squared minus 2x minus 24. Is it in proper standard form? Yes. Is the coefficient 1? Yes. And is the coefficient a 1? Yes. So we don't need to do any changes there. And it's also positive, so we don't need to do any changes there. So now we can move into the next step. And the next step is going to be move c to the other side, and let's call that the old c, because we're going to make a new c later. So since it's negative 24, we're going to add 24 to both sides. Okay, and now let's just rewrite it, and you're going to notice that I'm going to draw a space on the left and the right, and that's going to be so that we can fill that in the next step. Okay, space. And you could put a plus there because this will always be plus, equal to 24, that's from before, plus space. Now, remember that the space is a space for what I call the new c, and that's what we're going to create next. I paused the video and I wrote the formula for the new c, and I have that right here. The new c is to take b divided by 2, whatever that is, and then square it. So b over 2 squared. And remember to follow order of operations. So in this case, b would be negative 2. So let's fill that in. All right, and negative 2 over 2 is negative 1. And if we square negative 1, we get positive 1. So the new c we determined is 1. So we're going to add that to the left and on the right. That's why I left the space. And you may think that that's not that big of a deal, but the reason why I like to draw the line on both sides is to remind you to add it to both sides. Oftentimes, students will remember to write it on the left, but forget to write it on the right. And putting the line is just a little token to remind you to put it on the right side as well. Now before we move on, I want to just say one quick thing about the formula for the new c. b over 2 squared. In a strange way, this has a resemblance of finding the x or the h value of the vertex formula, because they just happen to look alike. But what I urge you to do is to not confuse them and not mix them up. It happens to be something that I've noticed a lot of students happen to do, and it's because they kind of look alike, sort of, and we kind of use them in both for quadratics. But please memorize them if you need to and be able to distinguish the difference between them, because they are different. Okay, so now that we have the new c added to both sides, the next step is to convert what is now, alright, and we created this to become a perfect square trinomial. And we could test that, but it is. So, because that's, it's made to create a perfect square trinomial on the left. And as you remember, hopefully, a perfect square trinomial always can be factored into a binomial squared. So the next step is to rewrite the perfect square trinomial on the left into a binomial squared. And in this case, this would become the quantity x minus 1 squared. Now we could test that if you want by multiplying it out or by doing the FOIL method, and if you test it, you would find that you get back to this formula. Okay, now also, if you're wondering, if you're looking at the details and wondering, how do you know it's x minus 1 and not positive 1? Well, this sign will be the same as this sign, and since this is negative, this is negative. That's where the negative comes from. Now, on the right, add the old c and the new c. 24 plus 1 is now 25. Okay, now we are not done with the complete the square method, but let's pause real quick, because I promised you that you could use the complete the square method and relate that to the vertex formula. Alright, so I'm going to explain briefly how to do that. Now notice on the left we have a quantity, x minus something squared, and on the right we have a number. But in the vertex form, we have also a quantity of x minus something squared plus k. Well, this is basically like negative k. So basically, if I move this constant to the other side by, in this case, subtracting, then in that case, this would become this. We don't need this, but we could say that this is y, and in this case y is 0. But now you can see how if we stopped midway through the complete the square method and moved the constant to the left with the parentheses and with the x squared, then now we have the vertex form of the quadratic formula. And from there, you could extract the vertex. The vertex h would be 1, and k would be, as it is, negative 25. Okay, that would be the vertex. That was not necessarily the focus of this video, but again, as I told you, this is all related, so now you can see how you can, another way to convert from the using the complete the square method into the vertex formula. So let me pause and erase that, and then we'll get back to solving the complete the square method, because we're almost done. Okay, we're almost done doing the complete the square method. So we're back to here, and now what we positioned ourselves so that we have a binomial squared on the left and a number on the right. And that's perfect, because that's what we want. The next step is to do the square root property. That just means take the square root of both sides. And we do that when we have a perfect square. So we're going to take the square root of both sides. Remember, it must be of both sides. And on the left, that happens to work out perfectly because the square root of a square equals the base. And in this case, the base is the binomial x minus 1. So the square root of x minus 1 squared becomes x minus 1. And on the right, coincidentally, we have a perfect square of 25. And the square root of 25 is 5. But remember, we have to take the plus or minus of that. So that's going to be plus or minus 5. And it's very important that now you remember to do the plus or minus when you take the square root, because we need to add or subtract those values both, because it's going to give us two answers. So now that we have plus or minus 5, what I'm going to do is break this up into two equations now. One with the plus 5 and one with the negative 5. So let's just do that over here where we have room. And let's start with the positive 5. So we have x minus 1 equals positive 5. And then let's do down here the negative 5. X minus 1 equals negative 5. Coming back to this one, all we're going to do is solve for x. And so since we have minus 1 here, we're going to add 1 to both sides. And 5 plus 1 equals 6, and we get x equals 6. All right? That's one solution. And now if we come to the negative 5 form, again add 1 to both sides, and negative 5 plus 1 is now negative 4. X equals negative 4. So there are our solutions, 6 and negative 4. Now, a little room here. I'm going to pause the video and draw a graph, and we're going to graph what we have. So I drew a graph, we squeezed it in right here, and let's use all the information that we have to graph this as best we can. This will still be a rough sketch, but it'll be somewhat accurate. So first, we used the complete the square method to solve, which means we found the x-intercepts. Let's plot those first. We have 6 and we have negative 4. Let's plot the 6 first, which would be 1, 2, 3, 4, 5, 6 here. And then the negative 4 would be over here, 1, 2, 3, 4. So we have the x-intercepts. All right, now what about the vertex? Well, before, when we had this, if you rewind the video, you would have seen that we have the h value will be 1. So that would be here. And the y value, if we move the 25 back to the left, it would come as negative 25. And basically, without counting, let's just say it's way down here. Okay? And so that would be the vertex. What about the y-intercept? Do we have that? We do. It's negative 24. And, all right, so keep in mind that the vertex is here. And the y-intercept is 1 above it, so let's put that right here, because that falls on the y-axis. And so now we already have basically the 4 details that we need. We have 2 x-intercepts, which we found by solving with the complete the square method. We have the vertex, which we also used from the complete the square method when we converted it into the vertex form. We could have also found it by the vertex formula if we started with this, which I went over in a previous video. And the y-intercept, we just grab that number. All right, and just one final detail, we'll do just to make sure it matches. Do we expect this to open upward or downward? Well, we look at A, and the sign of A is positive, so that means open upward, and that happens to make sense. So when we plot this and graph it, it looks something like that, okay? Not perfect, but good enough. And that pretty much completes the complete the square method. So before I end the video, let's just summarize the complete the square method. We started with this, and we made sure that it's in the proper form, which it was, standard form. This is C, and we moved that C to the other side. Then we wrote 2 spaces on the left and the right, and we took the two terms that were on the left and we used the new C formula, b over 2 squared. And remember, this is b. And we used that to find the new C. Once we found the new C, we put the new C and added it to the left and the right, both. Then, back on the left, that set us up into creating a perfect square trinomial. That's already created from the new C. From there, we factor into the binomial squared, and on the right, we just combine the terms. So then we have a binomial squared on the left equal to a number on the right. We take the square root of both sides, that gets rid of the square, and it leaves us with this. And then we have to remember that on the square root of the number on the right makes a plus and a minus. Make sure you have that. And then we break up the equation into two equations, one for a plus, one for a minus. And then we just solve for x in both, and they're the solutions or the x-intercepts. From there, we can plot them and then go from there. So anyway, that's the complete the square method. I hope you found this video helpful. In the next video, we're going to look at another method of solving quadratic equations, which is the quadratic formula. Also in a next video, I'm going to do one more example of complete the square method. That's going to be a little more complicated, not so much in the steps in the beginning, but just in the simplification steps at the end. I want to make sure that I go over at least one of those. So please join me in the next video, and thanks for watching.